So recently, a new president got elected in the United States, and I got worried about the environment. I mean, it's surely not a good sign for the ecology when the head of a planet's leading economy says, drill, baby, drill. In the last few months, however, I concluded that Idiocracy is a much harder science fiction than I previously estimated, and that Trump's overall impact on global ecology might be a bit more complex and controversial than I expected. From the events of the first half of 2025, it looks like the world is headed towards a global economical recession, which is good for ecology. Decline in our industry, transportation, and overall energy consumption is like a breather for nature. We've seen that, for example, during COVID and 2008 crisis. Even if recession is gonna happen, however, it's short-term, and Trump is still gonna leave a lot of long-term damage. Slashing funding for green initiatives, loosening the green laws, and encouraging hydrocarbon addiction will leave a lasting impact, and it will impact everyone. And sadly, it is not just Trump. In 2024, around where I live, in Europe, there were parliamentary elections, and among the biggest losers were the Greens. They got 19 less seats, which is a serious deviation from the overall European eco-friendly trend. It seems that local peoples are much more concerned about migrants recently. And well, also there's war. Yeah, we have a war going on nearby, one of the bloodiest military conflicts of the 21st century, and it bears its toll on both green initiative budget and ecology itself directly. War is real bad for ecology. Besides these probably finite issues, Europe still has its long-lasting problem of being addicted to the hydrocarbons from Russia and Middle East. Also, Germans are for some reason obsessed with not using nuclear power, which makes me think that peoples of Bundestag probably do not watch Kurzgesagt. But despite all that, Europe still does pretty well in climate protection, as well as, surprisingly, since recently does China. China is one of the main contributors to the climate change, sure, but in the recent decades they have invested in renewables on a scale unseen. Some countries that are rich in deserts also started to take advantage of solar energy. In fact, renewables are currently cheaper and thus more economically viable than hydrocarbons. So it is probably just a matter of time for the whole world to go green. However, we are still a very long way from that happening, and getting there will be very problematic, given what we have done so far and what we do now. There is such a thing as Doomsday Clock, a symbol of how close we are to the global reciprocal annihilation. It gets regularly updated by scientific peoples and currently stands on 89 seconds to midnight, which is, by the way, the closest it has ever been since the whole project began in 1947. While it is damn scary on its own, I believe we must also have some other scientifically endorsed symbol, some sort of Doomsday Thermometer that would show time remaining until the climate apocalypse. And we actually have one, but it is a bit confusing. I mean, now, in 2025, we know that the global average temperature has for the first time reached plus 1.5 degrees. But do we really understand what it means? What is that zero from which we count plus 1.5? How far had the temperature fluctuated from that zero in the past? Is it just a minor disturbance or a major problem, or is it the beginning of the end already? How bad is that plus 1.5? Well, to begin with, the 0 point on this scale is based on the average level of temperatures that we had when we started regularly recording those temperatures and could figure out the average, that is, since around the 1850s. By that time, we already had industrial revolution going on, but fossil fuels were not yet widespread worldwide, and their impact was minimal. That 0 point is not an actual Celsius zero, it is actually somewhere around 13.7 Celsius. However, in a certain way, it is very much a zero for us, Our whole human civilization has appeared and developed in Holocene epoch, during which global average temperatures stayed around that zero or slightly below it. In Quaternary, the larger time period that we live in, global average temperature had actually shifted quite a lot. It didn't go above +3 even in the warmest of times, and generally stayed below what we humans count as zero. The real average temperature point of Quaternary would lie somewhere around -3 degrees, something that I'd call Cold World. In Cold World, more water gets stored in the ice, ocean levels recede, and new landmasses appear. Global average temperature was holding plateaus of ice ages and interglacial periods below and above this level. These shifts happen due to a natural phenomenon known as Milankovitch cycles. The thing is, our planetary axis jiggles a little bit, and it's barely noticeable, but in the grand scheme of things, these tiny fluctuations can be totally game-changing. Every sliver of an angle matters, as does every fraction of the degree on the Doomsday Thermometer, as does every second on the Doomsday Clock. The next point going down, -6 degrees, is what I call the frozen frontier, and it sometimes was even colder than that, but not for long. By the frozen frontier, most of the Europe and North America were covered with glaciers. Alaska was connected to Kamchatka. Southeast Asia made up a subcontinent named Sundaland, while Australia with Tasmania and New Guinea were united into a continent Sahul. There was no Persian Gulf and Yellow Sea. Sea of Japan was a lake. New Zealand was one big island. In short, it was a very different world than the one we know today. The lowest point on the Doomsday Thermometer is -9 degrees, the gate of purgatory, which is a limit beyond which Earth isn't used to be. Averages very rarely were lower than -9 in Quaternary, and Quaternary is generally one of the coldest ages in the planet's history. It has been even colder than that, what is known as Snowball Earth, but it happened a very long time ago, before even multicellular life began, when the planet was learning to coexist with photosynthesizing microorganisms. I guess it's safe to say that life on Earth would undergo a major extinction event if the global average temperatures dropped beyond the gate of purgatory. But currently, that is absolutely not the direction we are headed to. The global average temperature has been rising a lot recently, and the point we are headed to is greenhouse light, the global average temperature of +3 degrees. We will reach it in just a couple of decades, and oh boy, does it not look pretty. Temperatures that high will melt a lot of ice, which will raise water levels worldwide. A lot of the coastal cities will either reinforce their coastline or get flooded. A lot of Greenland ice will be gone. Polar bears will probably go extinct in the wild. And Antarctica will probably start looking like a habitable place along the shorelines. I bet it might actually become quite a popular destination to move away from climate issues as we move up the Doomsday Thermometer, so my condolences to the penguins. Aside from that, by the greenhouse light stage, we will see dramatic decrease of ice on the mountains, which means less water in the rivers, which means drought. Lack of water and scorching heat is gonna devastate our agriculture, and the world will face mass famine. Rains are still gonna happen, but they will tend to be unpredictable and disastrous, hurricane-type events. In general, extreme weather events will become an everyday reality, and quite a lot of peoples will experience biome shift. Deserts are gonna expand and consume the adjacent plains and temperate forests, while the boreal forests will move further to the poles and colonize most of tundra. The next stage on the Doomsday Thermometer, +6 degrees, the base greenhouse, would take all these changes even further. There would be almost no ice, and all the permafrost will melt, releasing a shitload of methane into atmosphere, which will accelerate the warming even more. Tundra will collapse, deserts will grow, water will rise. But to be fair, life has actually survived in the base greenhouse conditions before. Life has actually thrived in ages way hotter than that. Like, for example, in Cretaceous, when most of the dinosaurs lived, averages shifted from the hardcore greenhouse of plus 9 degrees to what I'd call dinosaur sauna, plus 12 degree mark, and it had been even hotter than that. Not for much though, and not for long. The next mark on the Doomsday Thermometer would be plus 15 degrees, the fiery frontier. That is how hot it was during Ant-Permian extinction, which was much more radical than the one that wiped out the non-avian dinosaurs. Above the fiery frontier lies the Gate of Hell, plus 18 degrees, generally hostile to all multicellular life on the planet, the burning hothouse Inferno, and the penultimate point on the Doomsday Thermometer. The last one, plus 21 degrees, is what I call Destination Venus, because it would begin posing problems very much like those that Venus has, like overheated steamy atmosphere in which even microorganisms will perish. I mean, it surely won't be as bad on Earth as it is on Venus, but we will be moving in that direction for sure. And at some point, above plus 21, we might as well make our planet uninhabitable for life. That all, however, would be true only if we base our Doomsday Thermometer on the most recent data provided by Mr. Christopher R. Scottese and his colleagues. Scottese is a well-known authority in paleogeography and a proud owner of a hardcore beard. He has been updating his chart of ancient global average temperatures for almost a decade now, but in the end of 2024, another paper got published by Emily J. Judd, who used raw data sources and climate modeling, and her chart looked a bit differently. If it is correct, that would mean that we've been beyond that destination Venus, and the topmost point of Doomsday Thermometer would lie somewhere even higher. More than that, if our life forms have survived even plus 21, then there's a non-zero possibility that they can beat plus 24 degrees, or maybe more. So, we are still in kinda okay place for now, right? I mean, we are now moving from human zero to greenhouse light, and there's still a lot of steps left until we burn in scorching hellscapes, right? Well, there are several serious additional issues to consider here. First of all, it's speed. If we estimate maximum speed of the most recent and most well-known temperature changes, that is, between glacial and interglacial periods, it would be something around 0.06 degree per century or so. Since 1850, that change is happening per decade, which means the planet is warming up 10 times faster than it's used to. For the last 3 decades, speed was even higher, reaching up to 0.2 degree per decade. And that is more than 30 times faster. Like, here's my regular background soundtrack. And here's the same with 30 times acceleration. Feel the difference. Or think about it like that. Imagine that you are driving a car around a city where speed limit is 50 kilometers per hour. And now imagine someone driving around at 1500 kilometers per hour. That would be speed range typical for handgun bullets, supersonic aircraft, and space rockets. Why does this speed matter? Well, the thing is, changes in global temperature force nature to adapt and readjust. They are one of the main driving forces of evolution, and so far, nature has coped with them quite well. The biome shift speed left a time window for the old animals to adapt and for some new animals to emerge. And while the difference between the extremes of the frozen frontier and the fiery frontier might seem drastic, it took nature hundreds of millions of years to fluctuate between these extremes, and the speed of the average global temperature change was low. Sure, there were also times when that speed was way higher than current 0.2 degree per decade. Like after the impact of Chicxulub asteroid, it was like 10 to 20 degrees drop per decade. But well, that was for just a couple of decades, and it led to one of the worst known mass extinctions. So, I'm afraid we might have been building the wrong thing this whole time, guys. While Doomsday Thermometer certainly matters on its own, our current situation demands to look at something that I guess should be named Doomsday Thermospeedometer.
A needlessly complex word for a simple idea.
I apologize.
For now, it seems, we are moving through the city streets with the speed of a sonic jet, which sounds bad as it is already. As a forensic pathologist, I can assure you it's a guaranteed accident. But it appears we have not yet even hit the bottom. The thing is, a lot of our crucial planetary-level ecosystems, such as Amazon rainforest, permafrost, polar ice sheets, coral reefs, all have a certain tipping point of no return, when they stop acting as carbon sinks and start to accelerate climate change. People far smarter than me have explored the topic in detail, and it seems that the majority of these tipping points await us somewhere between +2 and +4, which means the speed of global warming will soon become even higher. That means, in essence, that it does not really matter that much whether or when will we reach the gate of hell on the Doomsday Thermometer. If we don't drop the speed of change, the speed alone will be bad enough to kill most of the wildlife and a lot of humans. According to my rough estimations, if we are optimistic and assume that climate change speed does not go higher than 0.2 degree per decade, we are gonna reach the destination Venus in around 1,000 years. But I'm afraid that near-death state might occur to nature much faster with us humans around. Even when the temperatures changed fast, before, there was still some space for biomes to move and readjust. But now they are heavily sequestered, and guess who has the most fertile and abundant plants? Well, it's us, humans. We use them for agriculture. And I'd make a bold guess that nature, under human burden, might undergo a near-lethal extinction event at the gate of hell, or possibly even fiery frontier mark. According to the pessimistic prognosis, we are gonna reach or even exceed base greenhouse level by the year 2100. Even in the best-case scenario, that is, if all the peoples of the planet unite in fight for climate and succeed, even in such a case, we are still gonna be in greenhouse light by the end of the century, and it will bring a lasting devastation worldwide. I guess in the very same way as the second half of the 20th century and the beginning of the 21st were shaped by the outcome of the World War II, the world of the peoples in the beginning of the 22nd century will get shaped by the outcome of the global climate collapse. So, what can we do to decrease this climate change speed right here and now? Why exactly is it so high in the first place? Well, it's mostly burning hydrocarbons. There are some other factors, like deforestation, cement production, or, for example, methane, which is orders of magnitude more powerful than carbon dioxide as a greenhouse gas, but that all still pales in comparison with hydrocarbons, coal, oil, and gas. Burning hydrocarbons produces that simple molecule, carbon dioxide, which works as a kind of a warm stuffing for the atmosphere. And the more there is of it, the thicker the blanket. When I was a kid, a teacher at school once explained what our air is made of, and she said there's 0.03% carbon dioxide. Now, in 2025, it's more than 0.04%. Yeah, I know 100% doesn't sound that bad, but it matters, in the same way as does every fraction of the planet's angle, as does every tenth of a degree on Doomsday Thermometer, as does every second on a Doomsday clock. And this exact 100% is the main driving force behind our 30 times the normal climate change speed. So, what can we do to have less of this carbon dioxide in the air? Well, it gets deposited in plants. They recapture it during photosynthesis and turn it into carbohydrates. Fossil hydrocarbons that we burn are basically layers of ancient carbon that got captured from the atmosphere during the entire history of our planet by the extinct animals and plants. So, to fix it, we need to stop burning, as well as plant more forests, as well as we can build special carbon capture stations. These already exist, but sadly are not very widespread. The good news is that, as I've already mentioned, renewable energy is currently cheaper than hydrocarbons, and it spreads around the globe more and more with every year. At a certain point, renewables might even completely replace hydrocarbons in all the major branches of economy, but we will be past the many ecological tipping points by that time, and a lot of irreversible damage will be done. One thing that I presume will help a lot is the crisping revolution that has been going on for more than a decade already, but will yet take some time to come to the full fruition. We've managed to create a lot of genetically engineered plants and animals, but that mostly was achieved via transplanting genes from the other organisms so far. Now, we have tech that predicts the shape of the protein molecules based on just their raw DNA code, as well as we can train AIs to do the bulk of the job. So we can kinda build new molecular structures, as well as code the entire new organisms. I would make a bold prediction that in the following decades, genetic engineering might become as widespread as, say, computer programming became in the 90s. And I believe it will get employed to solve a lot of climate-related problems. Like, for example, imagine algae that can produce ethanol from just water and atmosphere. Or imagine trees that are genetically programmed to pull as much carbon dioxide out of the air as possible, and then deposit it as compact bulbs deep underground. Or imagine whales that feed on microplastics in the same way as blue whales filter krill. Genetic engineering actually deserves its own separate video to explore it properly, which I will certainly do sometime in the future. But fortunately, nobody has to be a professional CRISPR to help the environment. With just several small, simple lifestyle changes, each and every one of us peoples can do his own little good to cool down that crazy Doomsday Thermospeedometer overdrive. A lot of information about that is available around the internet, so I doubt I'll tell you something really new here. I can, however, share some personal experience. My top 6 simple ways to do something for the environment that don't really demand much effort and monies. So first, the simplest one. Get yourself a good reusable bag. You can just fold it in your other everyday bag and avoid buying extra plastic bags every time you go to the supermarket. Next, it is a very good idea to sort waste. I know it's not available everywhere, but if it is around where you live, do it. It's simple and useful. Around where I live, the evolution of rubbish segregation system has gone far enough to differentiate cardboard, plastic, and metal from the rest of the waste. As well as we have separate spots to dispose of batteries, as well as there's bottle recycling system. Every bottled drink you buy comes with added 10-cent cost, which you can later get back by feeding bottles to the special machine. Also, recently I've had a spring cleaning and collected several bags of books and clothes that I felt I didn't need anymore. But I didn't throw anything away. I've dropped the clothes to the containers that collect textile for reusing and recycling, and took the books to the local charity shop that runs on donations. So, bottom line, if we reuse and recycle more stuff, we need to produce less new stuff, and that, in effect, lowers the overall carbon emissions. Third, I grow some plants on a balcony. It's not much, but it's a green spot that would have not existed if me and my girlfriend wouldn't have taken care of it. Then one of the most wasteful uses of the natural resources, and one of the key reasons why we are losing rainforests, is cattle farming. Cattle needs pastures, which are way less effective than forests in capturing and storing carbon. Also, cattle poops a lot, and that poop has a lot of methane, which is way worse than carbon dioxide. So, number 4, I don't eat mammals often. I am not yet ready to go full vegan, but when I can avoid pork or beef, I do avoid it and have either chicken or fish instead. Then next, I do not own a car. I do so by choice. There is actually nothing in the way of me getting it. I can afford it financially, I have a valid driver's license, I own a parking spot in the underground garage, and my everyday distance from house to work is big enough to want to drive it. However, I choose not to have a car and use local public transport instead. For me, it's kind of a win-win situation. I could have been concentrating on the road for half an hour, but I get to read a book for 40 minutes instead, which is way more useful and produces way less carbon dioxide. I know it's just not possible not to own a car in many places, as well as some of my friends ensured that you can't survive without a car if you have a kid. So that's probably not for everyone, but it worked just fine for me so far. Then the last, but certainly not the least, if you live in a democratic country, you can influence what your government does by voting and elect those who care about the environment. That is also not for everyone, since less than a half of peoples worldwide have the luxury of democracy. But if you do, I assure you, no migrants are as bad as what awaits us if we don't drop the climate change speed. So, if you know of some other, better and simpler ways to help the environment, please share them in the comments. Now, one last thing left to discuss in this video is the scientific plausibility of some climate apocalypse movies, which is something I usually do here on Hardcore Sci-Fi. You know, determine how hard is the science of fiction. And, well, sadly, the most well-known movie of this genre, The Day After Tomorrow, goes straight down to the cake tier of scientific plausibility, because it kinda points in the totally wrong direction. Snowpiercer does slightly better, since the freeze in the movie is expected to be a result of humans overdoing fight against climate change, via releasing of some highly potent freezing chemical that clouded the sun. Sadly, no known substance can be that effective, as well as that long-lasting, so the best I can say about Snowpiercer would be Vox tier, science fantasy. Waterworld might seem like hard sci-fi at first. In this scenario, all the world's ice melted and the water has risen so far that there's no land left, and everyone has to survive on the surface of the water on some boats or rafts. While the climate change direction is correct here, the extent of it is over-dramatized. We have a general understanding of how much land stays above the water even in the extreme hot periods when all the ice melts, and while it will certainly flood a lot of coastal cities and plains, there will be still a plenty of land left, just a lot of it will be a desert. So I guess I'll leave it at the average sci-fi level. Right direction, wrong execution. A similar thing happened in the anime Gargantia on the Verdurous planet, but it's kinda even worse here. We get at least some land in Waterworld, while in Gargantia that's it. All the surface of the planet is just one endless ocean. Well, there's nowhere near enough water to flood the planet that badly, the direction of climate change still is correct, so I guess I'll place it into the aluminum tier of mediocre sci-fi. Then in hard sci-fi tier, we have Mad Max franchise. It's an overheated desert with little to none vegetation, and the culprit is right on the scene. Hydrocarbons are still very popular among peoples, and there is still some industry, at the very least car and gun production. I find it a bit hard to believe that the collapse of civilization can be that global and that epic, and that nobody would seriously try doing, for example, reforestation, but still, Mad Max honestly earns his high spot on the tier list. Finally, in the top tier of hardcore sci-fi, we have two movies that are not actually about climate apocalypse. Instead, these are both about space travel. In both Interstellar and Mickey 17, climate change happens on the background. It's droughts, sandstorms, famine, economical crisis, and there's a lot of peoples who want to leave the Earth, because living in space apparently looks like a better alternative. So, yeah, I wish the hardcore sci-fi of our climate future looked somehow differently. I mean, I would surely prefer to live on a planet that feels less hostile to life than open space, but it is what it is for now. At the very least, we can try doing something about it, and it doesn't really require that much effort. Every little step matters, but we have to act fast, since the time has almost run out. So, I guess that's all I have to say on climate apocalypse scenarios for now. Thanks for watching. If you liked the video, leave a like, and if you'd like to see more like it, subscribe. That is scientifically proven to work. Stay hardcore, support your environment, and see you in the next video.